Hello everyone, my name is Gotino. My metric number is 60096. Very pleased to presentation about my FYP title. My title is for the routing electron for wireless network on chip. Now, my supervisor is Asrani. Presentation roadmap. This one is for the divided by some types. Firstly, research background. Secondly, motivation. Thirdly, problem statements. Fourth is research objective, scope of work, literature of review, research workflow, and your proposed work, and exceed the primary results and the conclusion. Now, the introduction. As the number of the cores integrated into the single chip increase, the role played by the on the chip convolution system becomes pivotal. The cost of solution area, performance, and energy consumption of the network on chip are common design optimization methods. For instance, the convolution electricity increased as the network size increased due to the multi-hop convolution network of the NOC-based systems. Now, wireless network on chip, WINOC. WINOC uses the wireless backbone on the top of the traditional wired based on NOC. WINOC introduced the long range and the high bandwidth radio frequency interconnections to reduce the multi-hop convolution in conventional of NOC platforms. Radio hops are utilized for single hop packet transfer between the remote nodes via wireless communication channel. Now, the focus on the WINOC architecture. Architecture is by 8 by 8, and 8 by 8 will be the why is for the 8 by 8 because it is usually for the 8 bits for that, but for binary. It's from 0, 0, 0, it's a 2 of the 2 power of 3 is 8. And the 2, 0, 0, 0 until 1, 1, 1. So it is for the A, for binary. And for the internal structure of tail nodes, this will be showed it will be the 4 directions: north, south, east, west. They will be rotor. Rotor, it will be the center of the of that. They will be hoop notion title with the source. Now, motivation of the research. Wireless interconnect can provide an energy of the effect combination while providing high bandwidth and low latency. Wireless interconnects can be used to transmit data across the chip in the one hop with the low energy. It will be the range of the negative 0.33 pg by bit and 1 by 1 pg by bit. This will be why because of the have 8 bits, 8 by 8, because it's for the 2 power of 3 digits for that 3-digit binaries that which requires the no waveguides or wireless. Compactly with CMOS technology and offers both gates and mostly gates and capabilities that are not easily assumed in the wireless. Now will be WINOC. They will be get between at the 12 points hopes. They will be have 12 poles, and each WINOC will be have one booth, north, west, east, north, west, south, north. Sorry, and that will be get 8 by 8 will be get 1 bit. And for research objective, this one is for the most important part. Firstly of all, to investigate the impact of the various routing algorithms in 64 cores mesh WINOC. Secondly, to make comparative analysis of the investigate routing algorithms on WINOC performance in terms of electricity, throughput, and energy consumption. Why is for the 64 cores? Because it's 8 by 8. Because 8 by 8 routing alternate models. So it's a 64 cores mesh WINOC. So the research workflow. The research workflow will have 4 steps. First step of all, and then to compare with the comparison with of the integrated works. And the second of all, the experimental works by using the Nielsen simulator. It will be focused on the C++ code, your C++ code, and your simulation, and that. And the evolution of the experimental work. This one is more focused on the results. Fourth is for the network performance compared with comparative analysis. Fourth, experimental step. They will be get because still until 0 between 63. They will be have 8 by 8. They will be get this one. This one is for the processor. This one is for the processor. Apply for the processor will be get output in the daily life. Usually about electricity and your simulation something is both divided by input, output, and input, output, and how to get from the input appear with the output is for the signal, output signal. Output will be the signal, and the input will be the output will be the signal, and the input will be that apply for this. It's dependent on the input. Enter the processor, apply for the processor, get output. And the output and the platform is one of the output, and divided by XY routing. Where's the first, negative first, north last, odd even. Now the simulation output example. Output example is that when you do your simulation that. Now when you get the simulation, you will be get appear these 3 platforms. The platform influencing the relation of the platform. Just now I have told the 5 things: X, Y, and lines that. And now conclusion. Memory communication technologies like WINOC are considered as a viable solution for facing the scalability, performance, and energy issues in many core system architectures. This one is for the conclusion. The conclusion is how you get when you look your what you do, what you learn about that. Do a similarly. You study at a book, you study at the website. So much ways to study. And then this one is for the reference. Reference is the most important for your work. It will be a promise you. It is your own work. Your own work applying. So, thank you, guys.